All right, activity 2.2, constructing and interpreting probability models. Okay, so basically a probability model appears to be where we are making a table and showing what the probabilities would be. Okay, so number one, construct a probability model for each situation. Explain how you constructed the model. Then determine whether or not the probability model is a uniform probability model. Okay. And so rolling an 8-sided polyhedron with the numbers 1 through 8. So my outcomes would be 1, 2, 3, 4, 5, 6, 7, or 8. An 8-sided polyhedron is like a 6-sided number cube, but instead it has 8 sides. Probability is 1/8 or 0.125. 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 And 1/8 or 0.125. All of those are the same. So this is a uniform probability model. Yay. B, choosing a marble from a bag of marbles containing 1 green marble, so green is an option, 2 red marbles, and 7 blue marbles. Let's see here. 1 plus 2 plus 7 is 10. So green would be 1 out of 10 or 1/10. Red would be 2 out of 10, which could be 1/5, which would be 2/10. Blue would be 7 out of 10, which would be 7/10. And when I look at that, I see that it is definitely not the same for each of those. And so this is a non-uniform probability model. Okay. C, selecting a member of the chess club whose members are Samuel, Martha, Carol, John, Sally, Ronaldo, and Simon. 1, 2, 3, 4, 5, 6, 7. Selecting a member of the chess club whose members supposed to be 1/7, 1/7, 1/7, 1 out of 7, 1 out of 7, 1 out of 7, 1 out of 7. They'd all be the same, so that is a uniform probability model. So it's uniform when it's all the same. It's non-uniform when it is different. 1/7 I could write as a decimal, but it is a repeating decimal. I know the sevenths have 7 digits, I believe, and then it repeats. D, selecting a male member of the chess club whose members are Samuel, Martha, Carol, Joanne, Sally, Ronaldo, and Simon. Always a guess. So the outcome is it is either a male or it is a female. The probability here for male is 3 out of 7. For female, it is 4 out of 7. And so this is a non-uniform probability model because they're not the same. Use the probability model to calculate each probability. So if I look here, probability of a 3 would be 3/12, which is the same as 1/4, which is the same as 25 hundredths, which is the same as 25%. For B, probability of an 8. Well, 8 is not a possible outcome, so the probability there is going to be 0. C, probability of a number less than 8. They're all less than 8. So that's going to be a probability of 1. A prime number. Tricky prime numbers here. Prime, prime, composite, prime, composite, prime. 1, 2, 3, 4 primes out of 1, 2, 3, 4, 5, 6 total numbers. So 4 out of 6. Wait a second. Have I made a mistake? Prime, prime, composite, prime, composite, prime. 1, 2, 3, 4, which is 2/3, which I could write as 0.6 repeated or be 66.6 repeated percent. Okay. Prime has exactly 2 factors, more than 2, so it's composite, exactly 2 factors, more than 2, so it's composite, and then exactly 2 factors. Okay, good. Then last but not least is an even number. So I look at my outcomes. Even, odd, even, odd, even, odd. It's asking for even. 1, 2, 3. So it would be 3 out of 6. 3 out of 6 would be the same as 1 out of 2, which would be the same as 5/10, which would be the same as 50%. All right. Let's see here. Going back. I like what I've done here. So I was looking at it theoretically, and I needed to not look at it theoretically. I see something wasn't making sense, and that's why I was slowing down. And this is going to happen to all of us from time to time. Probability of getting an 8. So this one's correct because it's 3 out of 12 for 3, which is 25% or 1/4. For an 8, it's not on there, so it's 0. So that's correct. A number less than 8 is 1, so that's correct. This is where I started making mistakes. So the prime numbers, I need to think about this a little bit further. The prime numbers here were 2, 3, 5, and 7. So I need to take those probabilities in the experiment, I would say. And so I would say it was 1/12 plus 3/12 plus 5/12 plus 1/12. When I add those together, I get 4/12, 9/12, 10/12, which would be the same as 5/6. So what I have here is wrong. Sorry. I needed to look at not just the outcomes, but how they are not uniform. So the results were non-uniform here. And 5/6 is the same as 0.83 repeated, which is the same as 83.3 repeated percent. Okay. Then last but not least, an even number would be the same kind of reason for this to be wrong. So I look at the even numbers here. So 2 is an even number, so 2 is 1/12. So I write down 1/12 below, which you cannot see. 4 is an even number, and that's 1/12. 6 is an even number, and that's 1/12. The other ones are odd. They're very unusual. And so I get 3/12, which I simplify to 1/4, or 0.25, or 25%. So I made a mistake on D and E. I'm ever so sorry. It's going to happen to me. And so I need to be mindful of if it is a uniform probability model, or in this case, what messed me up was this is a non-uniform probability model. But that is the end of our work on lesson 2.2.